Yeah, so good evening all. Probably we'll start within 2 to 3 minutes. Let's wait for others to join. So yeah, good evening all. Welcome to the NPTEL PMRF teaching session for week 12, which is problem solving discussion session. My name is Rituraj Singh Sujawat, who is Prime Minister's Research Fellow in Department of Earthquake Engineering, IIT Roorkee. I am working as an additional teaching assistant for this particular course, which is NOC 24C85, Finite Element Methods and Computational Structural Dynamics. So this particular course is currently being tutored by Professor Manish Khande, who is professor in Department of Earthquake Engineering, IIT Roorkee. So the objective of these 2 hour sessions are meant to interact with our learners. We'll be having discussion about some of the important concepts which required to solve the assignment problems available with us. We'll be solving some of the sample questions Also, we'll be having some doubt solving sessions. We'll be interacting with our learners who are engaged in this particular course. And other than this, if you are having any technical or non-technical query, be happy to take that. So let's start with this particular course. So this particular week session is meant to handle the problems related to Fourier analysis, and will be solving some of the problems. So you would have gone through the lectures of Professor Manish, who has covered the last session for this particular course, which is based on the Fourier series analysis. So we'll be dealing with the questions particular to that. So here is the first question in front of you. You need to obtain the 7-term Fourier series representations, including the zero value terms of the function ft. So the ft function is given to you. You need to obtain the 7-term Fourier series representation. So accordingly, you need to find the this particular uh, coefficient. So first you need to find the cosine coefficient a1, then you need to find the sine coefficient b3, and then you need to evaluate the f cap t at t equals to 2.0. So whatever Fourier series representation we have done in the f cap t, we need to evaluate that particular function. So you can try this for 2 minutes, and then we'll be solving this particular question. Yeah, hi Aishwarya.
Hello.
Yeah, so we have started with our this week's session. So this week's session is particularly meant for handling the Fourier series analysis problems. So how we can represent any of the function available with us using the Fourier function. So this is the first question available with you. You can try that, or you are having any particular query, we can also discuss that.
Third question of the assignment, something to draw with accelerogram.
Okay. uh, Assignment 12, right?
Assignment 1.
New codes, finite element methods, compositions. Is it that question? Identify an issue with the following pseudocode. Oh, sorry. It's week 12. Week 12 assignment 12. Okay. So what is the question? Free surface oscillogram for L center ground motion can be obtained from you. It is required to obtain the oscillogram. The soil deposit plot the oscillogram at the baclogram. Mention the maximum absolute value of the acceleration. So have you downloaded the ground motion?
Yes, yes.
Okay. now what has been load the accelerogram at the padlock level. So what is this plot is particularly meant for? It's a time versus acceleration graph, right? I'll just check with the like what the relations are as covered. Mhm. Plot the accelerogram at the bedrock level, and the free surface can be approximated with the natural frequency and damping ratio xi equals to 5%. You need to plot the accelerogram at the bedrock level and mention the maximum absolute value of acceleration. Have you understood the question?
No, I didn't understand. Like, no.
Okay. Let me first explain you the question physically. So actually we are from the earthquake department, so mostly we deal with the questions related to the earthquake. So yeah, let me check with my pointer. Yeah. So let's assume this is a particular. Yeah. So let's assume this is a particular section of the ground, and due to the seismic activities at the tectonic plates, uh, this ground will be subjected to some seismic activities. Let's assume this is your ground level where all the human lives exist. So let's assume that this is a built area available here. This is buildings, and let's assume this is a particular accelerogram. What is accelerogram? So it basically measures the uh, acceleration value with respect to time. So let's say this particular ground, due to some seismic activities, is subjected to some ground motions. So if you see particular plot of acceleration with respect to time, so this is how your ground motion looks like with respect to time. So these particular waves will travel to your accelerogram, and you will be measuring that whatever is the variation of the acceleration with respect to time. So let's say if this is a particular plot, on the y-axis you are having acceleration, and on the x-axis you are having the time. Okay. So let's say this is a movement of the seismic waves to the ground surface, and what has been asked in question. Okay, so let's assume this is the bedrock. So what do we mean by bedrock? So let's say this particular soil, this particular layer of the ground is composed of soil of, let's say, any type, and the layer beneath the soil is composed of bedrock. So usually we assume that whatever energy which is available at the base of the bedrock, that same energy will be available at this particular surface of bedrock also. Okay, so therefore whatever acceleration forces or whatever seismic forces available at this particular point, that same seismic forces will be available at this particular surface also, and those seismic waves will travel to the from the soil. So whatever seismic intensity which is available at this particular uh, base of the soil, that same intensity won't be available at the surface of the ground, because uh, in the soil you'll be having some of the damping properties. So what do you mean by damping? So whatever intensity of the seismic waves will be here, that will damp out. So due to some internal properties of the soil, that same intensity won't be available at the ground surface, and due to the attenuation. What do you mean by attenuation? So it will be basically decrease in the intensity of seismic energy, so due to the soil mass. So here you are having the accelerogram. So whatever data which has been given to you of acceleration with respect to time, that data is particularly meant for the data which has been recorded at the ground surface, so at the top of your soil layer. Now in the question you have been asked, like you need to evaluate that acceleration time history at the bedrock level. So what, from here the your seismic waves are transferring. So basically it is the origin at the vertical section of the ground, if I can say. So that particular energy has been transferred to your ground surface, so you need to evaluate. So here we are having the data. Okay, so and we have recorded that data, the intensity of data you need to find at this level, at bedrock level. So that what has been asked in the question. uh, are you clear now, like about the physics of the problem? Please ask if you have any doubt.
Just a minute.
Yeah.
The data is given at the top of the soil.
Yeah, the data is given at the top of the soil.
Okay.
So now you can go through the that particular session in the slides, the application of discrete Fourier transform or the fast Fourier transform, and now you can understand like how to transform this particular data so that we can obtain the original data at the ground surface, at the bedrock level. So there have been various methods which have been mentioned in the applications of DFT. So basically for the soil you have been given what is the frequency, natural frequency of the soil, and what is the damping ratio. So by utilizing these two parameters you need to evaluate what is the seismic intensity or what is the acceleration with respect to time data is available at the bedrock level. So that's what you have to do. Okay, then let's move to our question. Yeah, Aishwarya, did you get that?
No, the power cut down in my laptop. I just changed the
Yeah, it's fine.
just
No issue. So have you understood the physics of the problem which I have explained just now?
yeah, I understood.
Yeah. So now the only task you have to do, just go through the methods which has been given in the applications of DFT, and you need to see like how I can transform this particular data.
Okay.
Okay. So this is the applications of the Fourier analysis that which we have been covered. So okay, if there's no any query, let's move to our questions. So you have been given with a particular functions e raised to power minus t sin t plus cos t. We need to basically evaluate cosine coefficient, sine coefficient b3, f cap t at t equals to 2 second, and then we can find. So just take 2 minutes time, just see the question, try that. If not so, we'll be solving this particular question after 2 minutes.
I had doubt in Schmidt, Gram-Schmidt orthonormalization.
Hmm, that's a week one session, is it?
Ah, yes. I was doing it today. I don't know where I'm getting wrong.
Okay. What is the query? Means, can you show your question?
I'll tell you the matrix.
Mm-hmm.
V1 is 1, 2, minus 2.
B1 is 1, 2 minus 2.
V2 is 3, 1, 8.
What is the thing?
V2 is 318
Okay,
and V3 is minus 4, 3 minus 3.
minus 4 3 minus 3.
Hmm.
Okay. Uh, Let me check that. So
I have got even, but my E2 is coming 0. Actually, V2 bar is coming 0.
okay, so are you removing the traces properly, like from second one or third one? So
Yeah.
can you show your solution if possible? Because I just need to check with the Gram-Schmidt orthogonalization, like what is the particular formulation related to that. So give me 1 second. I'll just open my presentations. It was week 2, right?
Week 1.
Week 1. Okay. 2 minus 2. So this is the vector which I am having with me. So initially, let's say you need to select one vector. Is it visible?
Yes, it is visible.
So there are three vectors. So first you need to take the first vector, and you need to take the norm of that. And once you will take the norm of that, then for getting the second vector, you need to remove the trace of that particular vector from the new vector which you are having, so that the both the vectors are orthogonal to each other. So for doing that, what we do, so let's assume that this is your E1, and your E1 is 1 3 minus 2 in this particular case. So E2, you need to take Q1 and then Q1 transpose, and then you need to multiply E2, and then you need to subtract that particular from the E2. So are you doing the same?
Yeah, I'm doing the same, but my Q2 is coming 0.
Oh, okay. Did you check with the calculations?
Yeah, I have used similar formulas.
Okay. So 1 3. Okay. 2 1 minus 16. Shall I try that? Okay. Schmidt orthogonalization. Did you try with the hand calculations or MATLAB?
No, I'm doing hand calculations.
So E1 you have to take norm. So how much you are getting Q1?
Q1 is 1 by 3, 2 by 3 minus 2 by 3.
1 by 3, 2 by 3 minus.
2 by 3.
Okay. Now for getting the Q2 we need to remove input. So okay, let me obtain the octave. So let's say first you are having first you are having B1 as 1 2 minus 2, and you are having B2 which is 3 1 8, then you are having B3 which is minus 4 3 minus 3. If I'll run this particular code, I should be getting 3 vectors and selection command window. Okay, now we need to obtain the first particular now. So for getting Q1 I'll be having P1 divided by norm P1. So this is you're getting right.
Yes.
Now for getting the Q2 you need to take E2. You need to take E2. So your E2 is B2 minus Q1 into Q1 dash into E2 which is B2. This is your Q2, and then sorry, that was your Q2 cap. Q2 cap is equals to Q2. Then for getting the Q2 you need to take norm of this Q2 cap divided by norm of Q2 cap. Now let's check the orthogonality. Q1 dot Q2 1 second. How to take dot product in octave? So dot of q1 comma q2. Yeah, so it's giving 0, so both are orthogonal to each other. Can you check with your calculations? Means I'm not getting it as 0.
I'll check 1 second.
Yeah, means cause you can see my code, right?
Yes.
So probably might be problem like how you have evaluated q2 in your case, like whatever variable you have considered. Hmm. So yeah, you can check that.
Okay, thank you.
uh Anything else?
No.
Okay, so let's move back to our assignment. So we are having the particular code function available with us, which is ft equals to e raised to power minus t sin t plus cos t. You need to evaluate what is the cosine coefficient a1, sine coefficient b3, and accordingly you need to evaluate what is f cap t at t is equals to 2.0. So we are having the function available with us is ft is equals to e raised to power minus t sin t plus cos t. So to get the particular coefficients after the Fourier analysis, so after Fourier transformation, so the Fourier transformation is usually represented by ft is equals to a naught by 2 plus integral j equals to 1 to infinity. You will be having aj cos j omega naught t plus bj sin j omega naught t, and yeah, where your omega naught is equals to 2 pi by t naught. So in this particular, so this is how you are going to transform your function. So the challenge is to evaluate a naught, aj, and bj. So your a naught is usually given by yeah, your a naught is usually given by 1 by t naught, 0 से 0 to t naught by 2, and then you will be having ft dt. Your an is given by 1 by t naught, 0 to, okay, it's minus t naught by 2 to t naught by 2. You will be having ft cos j omega naught t dot dt. And in this case your j is starting from 1 2 3 going up to n. Then for your bn you will be having 1 by t naught minus t naught by 2 t naught by 2 ft sin j omega naught t dt. Your j will be evaluating from j1 2 3 going up to n. So this is how you will be transforming any particular function using the Fourier transformation. Just increase the number of slides. So this particular slide, so for our particular query you need to utilize this particular relations, and then you need to evaluate how our coefficients for after the Fourier transformation will look like. So one second, that's the issue with me. No problem, I'll start it again. Task manager. So yeah, for obtaining the coefficients for our case, so the so our function is given by ft e raised to power minus t sin t plus cos t and then dt. So for our case it is given by a naught 1 by p sorry a naught is given by 1 by 2 pi minus pi to pi e raised to power minus t sin t plus cos t dt. And similarly for the other coefficients, let's say an, we know that it is given by 2 by t naught minus t naught by 2 to t naught by 2. You will be having ft cos j omega naught t dt, where your j is going from 0 1 2 3 up to n, and your bn is going from 2 by t naught minus t naught by 2 t naught by 2. We'll be having ft sin j omega naught t dt, and your j is going from 0 1 2 3 up to n. similarly, for obtaining, for our case, your an is looks like something this. So that's why your an will be, for our case, 1 by pi, since your time interval is going from minus pi to pi, so that's why your t naught will be pi, and your limits of the integral is given by minus pi to pi e raised to r minus t sin t plus cos t, right? Why we are doing this? Because ft and then cos term will come. So similarly you will be having cos and t dt, and for this case the coefficients bn will be given by 1 by pi minus pi to pi e raised to r minus t sin t plus cos t sin of anti dot dt. Okay, so now which coefficients have been asked to us in the question? So you have been asked with a1, b3, and accordingly you need to evaluate 7 term series. So for 7 term series you need to take a naught term, then you will be having a1 corresponding to the cosine terms, then you will be having b1 corresponding to your sine term, you will be having a2, you will be having b2, you will be having a3, you will be having b3. So overall this will correspond to your 7 terms. So accordingly, for getting the third part you need to evaluate these 7 terms, 7 coefficients, and accordingly you need to write transform your ft function to the 7 terms function, and that will give you the Fourier series representation. So you can just plug the n value as 1 for getting the first part. So the answer which is there with me, okay, so I'm having the a naught terms, so you can use with, you can do with the hand calculation, or either you can try with some numerical tools. So a naught value is minus 3.676, a1 value is 5.881, b1 value is 4.411, e2 value is minus 1.47, b2 value is minus 4.411, a3 value is 0.3459, and your b3 value is 2.854. Come on. and your B3 value is 2.854. So accordingly, your Fourier series representation final after getting all the coefficients for your 7 terms is given by f cap t is equals to minus 3.676 plus 5.881 cos of t plus 4.411 your sine of t minus 1.47 cos of 2t minus 4.411 sine of 2t plus 0.3459 cos of 3t plus 2.854 sine of 3t. So these are your corresponding terms for the Fourier series representations f cap t. So this is the first part. It was pretty simple, like once you know the formulas, then just you need to plug the values of ft to those particular coefficient expressions, and by plugging the value of your coefficient number as per your interest, you will get those particular coefficients, and finally you can come to know what your Fourier series transformation looks like. So that was the first question. If you have any doubt you can ask. If not so, then let's move to our next question. So now there is a new functions given to you, which is ft is equals to t by p. You need to evaluate the cosine coefficients, sine coefficients, and you need to evaluate f cap t at t equals to p by 10. Okay, you also need to get the f cap t value at 2 seconds. So f cap at 2 seconds, the value which is available with me is 0.06674. Yeah, so you can try the second question. We'll discuss this after 5 minutes. So yeah, let's look to this particular question. So you'll be following the same relations which we are having with us. So in this particular case, your ft is given to you as t by p, right? And your function is given as t by p, and how to evaluate the coefficients for particular order. So your a naught is 1 by p, 0 to p, t by p, dt. Similarly, your an is given as 2 by p, 0 to p, t by p, cos of 2 and pi t by p, whole integral dt. Then your bn is given by 2 by p, 0 to p, t by p, sine of 2 and pi t by p dot dt. So this is how your coefficients will look like for this particular functions. Ft is equals to t by p. Okay. So in the question you have been asked to evaluate the cosine coefficients A0, sine coefficients B3. So accordingly the values which are available with me. So the anode value is 0.5, your A1 value and A2 and A3 are given to be 0. Why they are given as 0? Yeah, because when p term will get introduced, okay, either here t will cause the whole term to become 0, and then once you will do integral, you will put the limit p, this cosine term will get 0. Okay, then for the bn terms we are having b1 is equals to minus 1 by pi, your b2 value is given by minus 1 by 2 pi, your b3 value is given as minus 1 by 3. So the final f cap t which will be evaluating is minus 0.5 minus 1 by pi sine of 2 pi t whole divided by p minus 1 by 2 pi sine of 4 pi t whole divided by p minus 1 by 3 pi sine of 6 pi t whole divided by p. So this is how your f cap t will look like. Sorry, I'll try to make yeah, and you have been asked to evaluate f cap t at t is equals to p at 10. So you need to evaluate f cap t at this particular value of t, which is p by 10. Okay, so yeah, so f cap t at t is equals to p by 10. So the answer which is available with me for this particular value of f cap t at t is equals to p by 10 is 0.06062. Yeah, so that is the final answer. Yeah, so guys, any doubt in this? I think this is also straightforward. Once you know how to operate with the coefficients of the Fourier transform analysis, you can easily get to know how to evaluate them. So you can get a and bn, and accordingly you can evaluate f cap. So if you have done this is the last question for today. You need to obtain the discrete Fourier transformation in the solution. You need to obtain the absolute value of the second, fourth. So whatever we are doing till now was the transformation of the continuous function available with us. Now this is the particular area where you need to operate with the discrete values. So I guess the question which you have asked, Aishwarya, so in that similar case, uh, the data which has been given to you is not continuous, it's a discrete data, and somewhere to obtain like the convoluted data, so when you will obtain the response at the base of the bedrock, you need to perform the Fourier transformation of this discrete data. So these particular questions lies on the similar line. So just try with this. There have been some methods which have been given how to do the discrete Fourier transformation. We'll see to this particular question within 5 to 7 minutes. So let's check this question. So in this particular part, one second guys. So till now the values which till now the functions which we have observed in our area are particularly the continuous functions, but in reality if you check with whatever data you are getting particularly to your signals, they will be mostly your discrete data. So in that way you need to perform the Fourier transformation of the discrete data. So how to deal with that transformation? So to obtain the terms for that, your discrete Fourier transformation is given by, so let's say the different values of the discrete data that you'll be getting after the transformations, you can obtain it using this particular relation. So for the first term, you need to basically sum up all the values fi, where your I is going from 1 to n. So basically for getting the first value, discrete value after the Fourier transformation for your discrete data can be obtained by uh, summing up all these discrete values, and then you will get that particular initial value. So in our case, you need to obtain f naught by summing up the 0 plus 1.1 minus 2.3 minus 2.0 plus 0.0 plus 0.5 plus 1.8 plus 1.9 plus zero point 0.1 plus zero point 0.4, and that will give you the f naught value ultimately as 1.5. So this is the value of f naught. Similarly, to obtain the value of f1, so now the subsequent values of the Fourier transformation after discretization can be obtained as fn is equals to, this is the relation. So you will be having k starting from 0 going up to n minus 1, fk your exponential minus 2 pi n ki divided by n. So that will give you the subsequent values. So for, let's say, for obtaining the f1, uh, yeah, for obtaining the f1 you need to obtain f naught exponential minus 2 pi, and in this particular case your n is 1, your k is 0, and then multiply with I divided by n. Similarly, f1 exponential minus 2 pi 1 into 1 into I by 10 plus f9 exponential minus 2 pi into 1 into 9 into I by 10. So this will give you your f1 value. This will give you your fn value. So this is a similar context. So you need to take that fk value. You need to multiply whatever sequence number of your interest, and then whatever k is available, so you need to take that, and then you need to divide it by the total numbers. So n is your total number. So in our case we are having total 10 numbers, so n will be having the 10 value. Okay, so that is how you are going to deal with. And when you are saying I, so I is basically the uh, imaginary number, that is the iota, and it is not the particularly index. So similarly you will obtain the f2, f3 and so on up to f9. So the final, so you can either do the hand calculations or you can run a for loop in any of your language, and you can operate with this thing. So your f1 value, so the answer which are having with me is, so your f naught is anyhow is 1.5, then your f1 is minus 1.3916 plus 6.6382 iota, and then your f2 is 3.3805 minus 3.2593 iota, then your f3 is given as 1.2916 minus 2.6569 iota, then your f4 is given by minus 2.8805 minus 0.042878 iota, your f5 is given by minus 2.3 minus 9.1849 iota. Okay, it's e raised to power minus 16, so I guess this value is only minus 2.3. Then your f6 value which I am having with me is minus 2.8805 plus 0.042878 iota. Your f7 value which is available with me is 1.2916 plus 2.6569 iota. Then your f8 value which is available with me is 3.3805 plus 3.2593 iota. Then f9 value is minus 1.3916 minus 6382 iota. So once you will get all these f values, you need to take the absolute values to get the final discrete your discrete values for the Fourier transformation, because you can't represent these numbers in the real space. So that's why we'll be considering the absolute values of all these particular imaginary numbers which we got till now. Okay, so the absolute values of f which is available with me is 1.5, 6.7, 825. Yeah, so I think you can obtain the rest of the absolute values to get the final discrete values. So that was how you are going to perform that discrete transformation, sorry, Fourier transformation for your discrete data. So this is how you will be getting the initial values, and all the subsequent values you can get it by using this particular relations, and by utilizing this all the values you will getting the subsequent values. So these are the answers in front of you. For final answers you need to take the absolute of all these imaginary numbers, and this is how you're going to perform the Fourier transformation for your discrete data. uh, so any doubt till here? Okay, if there's no any doubt, let's move to the last question. So yeah, the last question is yeah, one value answer, and that too based on the third question. So you need to evaluate what is the dominant frequency. So what do you mean by dominant frequency? So whatever Fourier transformation which you have performed, you need to obtain the most dominant frequency from that particular data, and that will give you the dominant frequency. And once after you will do the you will be getting the absolute values of all these particular imaginary numbers, and accordingly you will be obtaining the dominant frequency. And so the answer which is available with me is your second value, which is the 6.7825. So this was your dominant frequency. So yeah, that was the final question for today. I don't have any other sample questions related to this particular topic, so we need to wind it up here only. But I'm happy to, like, please feel free to ask if you guys have any doubt in any of the topic. We'll try to solve it together. Yeah, so Ishwarya, did you get the? Okay, no problem. So did you get to know how to solve the third question? That what was the thing? You need to obtain the acceleration, right, at the base of the bedrock, at the top surface of the bedrock. So, like, even I haven't tried that particular question, but we can try it now if it's okay for you.
You can explain. I was still doing that third question.
Okay, okay, okay. So let's check that. Even I haven't seen that, but yeah. So let me.
This long questions will come for Fourier series.
Not sure, actually. Yeah, it depends on the time, and I guess even though they won't commit directly, but Not sure. Definitely, I can't comment on that.
Okay, thank you.
Yeah. So I guess this is the particular topic we need to deal with. So yeah, you need to perform the convolution and deconvolution. So there was a particular figure which can describe our problem of interest. Yeah, so deconvolution is the process of reconstructing the input signal from the response by reversing the effects of convolution on input signal to produce the response. So yeah, that particular process where we are uh, reconstructing the signal. So whatever signal which we are getting at this particular free surface, we are basically going to reconstruct it. So the transformation of the signal from the bedrock to the free surface is known as convolution, and when you again reverse that particular signal to obtain that signal at the bedrock, that process is known as the deconvolution. Can I write this here? Yeah, I can write it here. So yeah, can I use eraser? Yeah, I can use eraser. So for our case, we have been given with the data, discrete data, which is available at this particular surface, and we need to evaluate what is the signal here. So frequency response function h omega 4 soil is developed from an analytical model and considered as the response of the soil deposit. Okay, so you need to obtain the h omega function because the frequency response function is your h omega for the soil layers is developed from an analytical model, and the recorded free field ground motion is considered as the response of the soil deposit. So whatever acceleration you are getting here is your response of the soil deposit. So here it has been given how you are going to evaluate h omega. So 75% of the power in free surface motion can be attributed to vertically propagating shear waves at frequency up to 15 hertz. Okay, so whatever signal which we are getting, 75% of that particular power in the free surface motion is corresponding to your shear waves, which is at frequency up to the 15 hertz. So this is intuitive. Typically a 15 hertz low pass filter is used to eliminate the spurious amplification of high frequency leading to unreasonable large acceleration. k, so that the desired frequency response constant for the soil deposit is then obtained as. So you need to evaluate the h omega. So how to obtain the h omega? So it's z bar omega by xf bar omega, and the absolution acceleration response. Yeah, so you are having this particular response available with you, and you need to evaluate this particular response. And you how can you obtain the xf omega? Let's look to that. xf omega is basically so only thing we need to evaluate how to obtain the x bar f omega. So in the question, the data which has been given to you, so is there any analytical relation which is available which will can give you the free surface response? Let me check in the slides. Hello. Yeah, Aishwarya, are you there?
Yes.
Yeah. Actually, I got confused. Means I haven't seen the this particular session. The only thing is the evaluation of the HW. So right now, the data which is available to you is the data which is the response recording of the response at the free surface, right? So using that particular data, you need to evaluate what is the applied motion at the bedrock level. So yeah, so this is the particular mm, like relation we'll be using to get what is the applied ground motion at the bedrock level. So this is the XF capped W. So do you understand what this denotation is for? So right now, like the data which is available to us is in the time domain. So your acceleration data which is available at the one axis, you are having the time domain, and at the another axis you are having the acceleration response, right? So to perform the like deconvolution, you need to convert the data which is available to you in the frequency domain. And once your data has been converted to your frequency domain, you need to apply this particular relation. So this is your data which is available in the frequency domain, and then this HW is basically your some analytical relation. So I'm not sure whether it has been mentioned here. So the frequency response function HW for soil area is developed from an analytical model, and the recorded field is considered as the response. So you need to find it out like what is this HW is. So once you will get your HW in the frequency, the value in the frequency domain, so you can convert this particular data which you have converted into frequency domain. You need to divide it by the HW, and then you will get it what is your ground motion available at the bedrock level. And whatever data you will be getting it here, that too will be in the frequency domain. For your final answer, to give it again, you need to again perform the Fourier transformation, like inverse discrete Fourier transformation, to convert that data into time domain, and then you need to report your answer. So that is how you need to deal with that particular question. SW, I need to look into that part, but yeah, I'm pretty sure like Professor Manish would have mentioned in his lectures what is the SWs. But yeah, the overall philosophy flows like this. So you are having your data at the free surface, you need to convert it into frequency domain data. That frequency domain data, you need to convert it into using that data you will determine what is your recorded, what is your input ground motion in the frequency domain looks like, and that obtained input ground motion in the frequency domain, again you need to convert into time domain using the inverse discrete Fourier transformation. So did you get it? What did I say?
Yes.
Okay. So the only challenge like I need to encounter is what is your SWs. Means I know some of the your SW functions, but I'm pretty sure Professor Manish would have reported some other particular things. So you need to go through the sessions. I'm pretty sure you will get it. What is that particularly meant for? So any doubt in this? So only thing is like you need to perform the Fourier transformation, and you need to do all the calculation in the frequency domain. Once your all the results have been computed in the frequency domain, you need to again convert it into the time domain using the particular thing, which is the inverse discrete Fourier transformation, and once that has been performed, you can report your results. So that is how it looks like. I would have done it here, but yeah, since the assignment date is due, I can't solve it fully, so I have just given you conceptually how you can proceed with the thing. So maybe you can point it out in the YouTube video comment. I'll try to answer that there if you don't get the final answer. So any query? Okay, thank you, Aishwarya. So I'm not sure whether we'll be having the last means week 13 or not, the teaching assistantship session, but yeah, since 12 weeks are over, so most probably this is the last interactive session um, for this particular course. But no problem, you guys can anytime reach out to me via the YouTube channel. You can post your queries in the comment section of the YouTube channel, and I'll try to address it there. So thank you guys for your time, and most probably let's see if for the next session we'll be having this particular course, or if I'll be selected as an additional teaching assistant. Let's meet at that time, but you guys can anytime post your query in the comment section. Thank you. Yeah, Aishwarya will be getting code in exam. uh, First of all, I'm not sure whether they'll allow you to use any particular coding language or not, and if they'll allow, in most of the cases you will never get the code to solve your exam. So if they'll allow the particular, let's say, numerical tools, either your laptop, or let's say wherever you'll be giving your exams, you need to come up with your own code. I'm not sure, I haven't seen how the NPTEL conduct the exams, and particularly in that subjects where you need to utilize the code to solve the questions. I think I'm not the right guy to answer this question. You can answer in the discussion forum. Other TA told mostly smaller problems. Are okay. So are those are these TAs are those who are available on the discussion forum, or is it from the interactive session only? So the other TA who is I'm not sure, Mr. Ram, I guess. Did he told that particular thing? Okay. So actually I'm not sure. So yeah, you can ask from other people. So there are different formats. They how the way they'll give the exams. Yeah. So overall, I'm not sure whether you can use it or that particular thing or not. Okay. So okay, guys. So all the best for your exams. Don't panic. Whatever will come, you guys had already covered in the assignments, so just be confident that you can address the questions there properly. So all the best once again. So thank you. I'm closing the session. Thank you for your time. Yeah. Thank you, Aishwarya.